This is a minimization problem, so it's non-standard. It has three variables, x, y, and z, and three constraints, all of which are greater than or equal inequalities. So what we have to work with are the three constraints shown here and the function that we're minimizing. To work our way toward the initial simplex tableau, we start by converting all the greater than or equal inequalities to less than or equal inequalities by multiplying each of those by -1. That's what's shown right here. We also change the minimization problem to a maximization problem by letting D represent -C, which would be -15x, -30y, -35z. And we're going to maximize D. Once we have this, we can introduce the slack variables, u, v, and w. We've rewritten the function, the equation for D, in standard form. So from this, we have everything we need to go straight to the initial simplex tableau. Make sure that you know how to do that. Here is our initial simplex tableau based on those equations we were just looking at. Be absolutely certain that you know how to get to this tableau from those equations. That's critical to being able to use the simplex method. You can't use it if you can't get your initial simplex tableau set up correctly. We have negatives in the far right column, so I focus on one of them, slide over to the left, pick any negative number over here to the left of the -24. I'm going to come to the first column because these numbers look easy to work with. -1 into -24 is 24. -2 into -32 is 16. And 28. So the 16 is the smallest positive ratio. That corresponds to the 2 here. I'll pick that 2 as my pivot element. So I'll click the pivot on selection button. And I've completed the first step in the simplex method. I still have negatives over here on the far right. So let's pick another one of these and then slide over to a negative number to its left. I'll come to the -2. -2 into -8 is 4. This ratio is 16. This ratio is 6. So the -2 into -8, 4, that's the smallest ratio from that column. -2 is the pivot element. Let's pivot on it. I've now finished 2 steps. I still have a negative in the far right column, so I'm still not in the solution region. I look at this -4, slide over to some negative number to its left. I'll come to this -1. Ratio of 4, -1 into 4. Ratio of much bigger. And this is not a positive ratio at all. So -1 into -4 plus 4 is the smallest positive ratio. I pivot on the -1. And now I'm done with the far right column. Remember, you never have to pay any attention to this spot down here. But I still have a negative in the bottom row. So now, based on this negative in the bottom row, I have to pick a pivot element from this column. 2 into 4 is 2. That is bigger. This 1.25 into 6 is also bigger. So the 2 into 4 ratio of 2 is my smallest positive ratio. I pivot on the 2. And it appears I'm done. No negatives here. No negatives here in the bottom row except this one over here, which doesn't count. So I'm done. Let's interpret what we have from this final simplex tableau. Okay, let's take our final simplex tableau and relate it back to the original question. What's the minimum value of C? Well, the maximum value of D is shown in the tableau. Here's the 1 in the D column. Minus 317.5 is the maximum value for D. So the minimum value for C would be plus 317.5. So 317.5 is what goes in for the minimum value of C. What values for the variables produce that minimum value for C? Well, the x value at the optimal solution, come down to the 1 in the x column. The x value would be 9.5. That would go here. The y value, the 1 in the y column, corresponds to the 3.5 value. Y would be 3.5, and z would be 2. So 9.5, 3.5, and 2 are the values for x, y, and z, which produce that minimum value for C. We're not asked about the slack variables, but you can see from these three columns, none of these columns is in unit form, so all the slack variables are equal to 0 when the minimum occurs.